to determine the load for a 208/120 volts three-phase system, firstly, gather the necessary equipment data. This involves creating a comprehensive list of all electrical equipment present in the area, including the water heater, air conditioning unit, workstations, pedicure chairs, washer and dryer, and lighting. For the water heater, obtain its wattage rating. For the air conditioning unit, note its rated current and power. For the workstations, estimate the total wattage or the number of appliances connected. For the pedicure chairs, find the wattage or motor current. For the washer and dryer, get their wattage or rated current. Finally, estimate the total wattage for the lighting. Secondly, calculate the amperage for each piece of equipment. For the water heater, use the formula amps equals wattage divided by voltage divided by 1.732. For the air conditioning unit, use the rated current from the unit's label directly. For all other equipment, use the same formula as the water heater, amps equals wattage divided by voltage divided by 1.732, or use the rated current for motors if available. Thirdly, determine the total amperage by adding all the individual amperage values calculated for each piece of equipment. Fourthly, consider adjusting for the power factor. However, for most electrical equipment, the power factor is often close to 1, so this step can usually be omitted. Fifthly, derive the calculated load. Reduce the total calculated load by 20% to provide a safety margin and account for any future expansion or additional equipment. The formula to use for load calculation is load in kilowatts equals amperage times voltage times 1.732. This formula assumes a three-phase, three-wire system with a line-to-line voltage of 208 volts. If the system has a different line-to-line voltage, adjust the formula accordingly. Also, ensure that the panel board has sufficient capacity to handle the additional load. Several resources can simplify this process. You can use a spreadsheet or specialized load calculation software. Some software programs are available online, including Electrical Load Calculator, LoadCalc, and iCircuit. Electrical Load Calculator can be found at Calculator. net/electrical load calculator. HTML. LoadCalc can be found at LoadCalc.com. iCircuit can be found at iCircuitapp.com. These tools can automate the calculations and help ensure accuracy. Remember, the formula provided assumes a three-phase, three-wire system operating at 208 volts line-to-line. If the system has a higher line-to-line voltage, make sure to adjust the formula appropriately. It is essential to ensure that the existing panel board has enough capacity to handle the new load being added, including the 50-gallon electric water heater and other equipment. It is always recommended to consult with a qualified electrician for professional guidance and to verify the calculations, ensuring safety and compliance with local electrical codes. They can provide expert advice tailored to the specific circumstances and ensure that the electrical system is safe and reliable. When gathering equipment data, pay close attention to the voltage requirements of each device. In a 208/120 volts three-phase system, some equipment might operate at 208 volts, while others operate at 120 volts. Ensure you use the correct voltage value in your amperage calculations. For example, if a piece of equipment is rated for 120 volts, use 120 volts in the formula, otherwise, your calculations will be inaccurate. When calculating the total amperage, consider any diversity factors that might apply. A diversity factor is a ratio that reflects the fact that not all equipment will operate at its maximum load simultaneously. For instance, the pedicure chairs might not all be running their circulating pumps at full capacity all the time. If you can reasonably estimate a diversity factor, applying it can result in a more realistic load calculation. Remember that adding a 50-gallon electric water heater can significantly increase the load on the electrical system. Electric water heaters typically have high wattage ratings because they need to heat water quickly. Be sure to account for this substantial load when calculating the total amperage. Furthermore, consider the placement of the new water heater. It should be located in an area where it can be easily accessed for maintenance and repairs. Also, ensure that the location complies with all local plumbing and electrical codes. The electrical connection should be made by a qualified electrician to ensure safety and compliance. When determining the total amperage, it is also crucial to consider the starting current of motors, such as those in the air conditioning unit, pedicure chairs, washer, and dryer. Motors often draw a much higher current when they start than during normal operation. This inrush current can briefly overload the electrical system. To account for this, you might need to use a higher ampacity conductor and a circuit breaker with an appropriate time delay. Always consult with an electrician to ensure that the wiring and circuit protection are adequate for the motor starting currents. Power factor correction can sometimes be beneficial, especially in commercial settings where there are many inductive loads, such as motors and fluorescent lighting. A low power factor can cause the electrical system to be less efficient, resulting in higher energy bills. Power factor correction involves adding capacitors to the electrical system to improve the power factor. While omitting this step might be acceptable for initial calculations, it is worth considering for long-term efficiency and cost savings. When directing the calculated load by 20%, this is a conservative approach that provides a buffer for safety and future expansion. However, depending on the specific circumstances and local codes, you might be able to use a different directing factor. Always consult with a qualified electrician to determine the appropriate directing factor for the situation. They can take into account factors such as the type of equipment, the duty cycle, and the ambient temperature to determine the most suitable directing factor. If the existing 100 amps panel is close to its maximum capacity, consider upgrading to a larger panel to accommodate the new load. Overloading an electrical panel can be dangerous and can lead to overheating, electrical fires, and equipment damage. Upgrading to a larger panel provides more capacity and ensures that the electrical system can safely handle the load. An electrician can assess the existing panel and determine whether an upgrade is necessary. Also, ensure that all electrical work complies with the National Electrical Code, or NEC, and local electrical codes. The NEC provides detailed guidelines for safe electrical installations, including conductor sizing, overcurrent protection, grounding, and bonding. Local codes might have additional requirements that must be followed. Compliance with these codes is essential to ensure the safety and reliability of the electrical system. When using load calculation software, always verify the results manually to ensure accuracy. Software can be helpful, but it is not a substitute for professional judgment. Double-check the input data and the output results to catch any errors or inconsistencies. Also, be aware of the software's limitations and assumptions. Some software might not accurately model certain types of equipment or electrical systems. When consulting with an electrician, provide them with all the relevant information about the electrical system and the equipment being added. This includes the equipment data, the calculated load, the existing panel capacity, and any specific concerns or questions. The more information you provide, the better the electrician can assess the situation and provide appropriate recommendations. Always keep detailed records of all electrical work, including load calculations, wiring diagrams, and inspection reports. These records can be helpful for future maintenance, repairs, and upgrades. They can also be useful for demonstrating compliance with electrical codes. Also, consider energy efficiency when selecting new equipment. Choose energy-efficient models that consume less power and reduce energy costs. Energy-efficient equipment can also reduce the load on the electrical system, which can be especially important if the panel is close to its maximum capacity. Look for equipment that is ENERGY STAR certified or has a high energy efficiency rating. When calculating the load for lighting, use the actual wattage of the lighting fixtures. If you are using LED lighting, the wattage will be much lower than traditional incandescent lighting. LED lighting is much more energy efficient and can significantly reduce the load on the electrical system. Be sure to account for this when calculating the lighting load. When adding new circuits, use the appropriate size conductors for the load. The conductor size must be large enough to carry the current without overheating. The NEC provides tables that specify the minimum conductor size for various opacities. Also, use the correct type of insulation for the application. The insulation must be rated for the voltage and temperature of the circuit. When installing new receptacles, use tamper-resistant receptacles, especially in areas where children might be present. Tamper-resistant receptacles have a built-in safety mechanism that prevents objects from being inserted into the slots. This can help prevent electrical shocks and injuries. When installing new ground fault circuit interrupters, or GFCIs, use them in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against ground faults, which can cause electrical shocks. They quickly interrupt the circuit when a ground fault is detected, preventing serious injury. When working with electrical systems, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and gloves. De-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Never work on electrical systems when you are wet or standing in water. When making electrical connections, use the correct tools and techniques. Use wire strippers to remove the insulation from the conductors. Use pliers to twist the conductors together. Use wire connectors to secure the connections. Make sure the connections are tight and secure. When inspecting the electrical systems, look for any signs of damage or wear. Check for cracked or broken wires, loose connections, and overheated components. If you find any problems, repair them immediately. When testing electrical systems, use appropriate testing equipment such as multimeters and clamp-on ammeters. These tools can help you measure voltage, current, and resistance. Use the testing equipment safely and follow the manufacturer's instructions. When troubleshooting electrical systems, start by identifying the symptoms. What is not working correctly? When did the problem start? What have you tried already? Use a systematic approach to isolate the cause of the problem. Consult with a qualified electrician if you are not comfortable working with electrical systems. Electricity can be dangerous, and it is important to work safely. Ensure all components used are rated for the specific application, considering voltage, current, and environmental conditions. This includes the water heater, wiring, breakers, and any other related equipment. Confirm compliance with local codes and regulations, as they may have specific requirements for electrical installations in nail salons or similar commercial spaces. This might involve permits, inspections, and adherence to specific safety standards. Periodically inspect the electrical system to identify any potential issues early on, such as loose connections, frayed wires, or signs of overheating. Addressing these problems promptly can prevent more serious problems and ensure continued safety. Consider implementing surge protection to safeguard sensitive electronic equipment from voltage spikes. Surges can damage equipment and disrupt operations, so surge protection can provide valuable protection. When making any modifications or additions to the electrical system, update the electrical panel directory to accurately reflect the changes. This helps in identifying circuits and simplifies troubleshooting in the future. Ensure that all electrical work is performed by qualified and licensed electricians who have the necessary experience and training. This ensures that the work is done safely and correctly, minimizing the risk of problems and ensuring compliance with codes. Regularly test ground fault circuit interrupters to verify that they are functioning correctly. GFCIs are designed to protect against electrical shocks, so it is important to ensure that they are working as intended. Consider using a power quality analyzer to assess the overall health of the electrical system. This tool can identify issues such as voltage fluctuations, harmonics, and other power quality problems that can affect equipment performance and efficiency. If the nail salon plans to expand or add more equipment in the future, factor this into the load calculations to ensure that the electrical system has enough capacity to handle the additional load. This helps avoid overloading the system and ensures reliable operation. Implement a preventative maintenance program for the electrical system to keep it in good working order. This can include tasks such as tightening connections, inspecting wiring, and testing components. When replacing equipment, consider upgrading to more energy-efficient models to reduce energy consumption and lower operating costs. Energy-efficient equipment can save money on electricity bills and help reduce the environmental impact. Ensure that all electrical equipment is properly grounded to provide a safe path for fault currents. Grounding helps prevent electrical shocks and reduces the risk of equipment damage. When using extension cords, use heavy-duty cords that are rated for the amperage of the equipment being powered. Avoid using multiple extension cords plugged together, as this can create a fire hazard. When working with electrical panels, use insulated tools to prevent electrical shocks. Insulated tools provide a barrier between the user and the electrical current, reducing the risk of injury. Ensure that all electrical boxes are properly covered to prevent accidental contact with live wires. Covers help protect against electrical shocks and reduce the risk of fire. If there are any exposed wires, repair them immediately to prevent electrical hazards. Exposed wires can cause shocks, fires, and other problems. Ensure that all electrical components are installed in accordance with the manufacturer's instructions. This helps ensure that the equipment operates safely and reliably. When working with electrical systems, use a buddy system to provide support and assistance. Having someone else nearby can help in case of an emergency. When leaving the workplace, turn off all unnecessary electrical equipment to conserve energy and reduce the risk of fire. This can help save money on electricity bills and reduce the environmental impact. Regularly train employees on electrical safety practices to ensure that they are aware of the hazards and know how to work safely. Training can help prevent accidents and injuries. Implement a lockout-tagout procedure to prevent accidental energization of equipment during maintenance and repairs. This helps ensure that the equipment is energized and safe to work on. Maintain a safe working distance from energized equipment to prevent accidental contact with live wires. This helps reduce the risk of electrical shocks and injuries. Use ground fault circuit interrupters in all areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against ground faults, which can cause electrical shocks. Regularly inspect electrical cords for damage and replace them if necessary. Damaged cords can cause electrical shocks, fires, and other problems. Avoid overloading electrical circuits, as this can cause overheating and fires. Follow the manufacturer's instructions when using electrical equipment. This helps ensure that the equipment operates safely and reliably. Never attempt to repair electrical equipment unless you are qualified to do so. Electricity can be dangerous, and it is important to work safely. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. They can provide expert advice and ensure that the electrical system is safe and reliable. Remember, safety should always be the top priority when working with electrical systems. Take the time to follow safe work practices and consult with a qualified electrician if you have any questions or concerns.